Okay, so we have discussed about the vectors, right? So in the vectors, right, so there is something called dividing the vectors into components. So earlier actually we have divided the vectors into the perpendicular components. Now actually if I ask you to divide the vector into two different components but are of not perpendicular to each other. Let us say dividing a vector into components, we mean suppose if this is the vector, then I am trying to identify two different vectors whose sum is equal to this vector. So this vector actually, the way we divide it is, so this is one vector which we say as horizontal component, and this is another vector which is a vertical component. So this, if it is r, then this is r cos theta and this is r sin theta, and this is the angle theta. So this actually simply we were able to find out with the basic trigonometry rules, that is cos theta is equal to x by r, and where x is equal to r cos theta. Now actually if I ask you to divide this vector, the same vector r, into two different components, so one vector which is equal to p with an angle of alpha and another vector which is magnitude, so this is q vector and an angle of beta, then actually can you divide this vector r into p and q? Or can you give me an idea how can I divide this vector r into the components, one component at an angle of alpha and another component at an angle of beta? So these sum should be equal to r. Can somebody give me an idea how we can approach this kind of problems? Anybody? Any idea? Any idea how we can solve this? So this actually straight away it is easy. So this is x and this is y. Cos theta equal to x by r and sin theta equal to y by r, and x is equal to r cos theta and y equal to r sin theta. But actually now I am asking to divide this vector into an angles alpha and beta. Now actually to handle this kind of problems, now actually I will give you a simple approach. See this. The sum r should be equal to p plus q. This is a basic condition because we are dividing the vector r into two different components whose sum should be equal to r. Right? Yeah. So shifting the base may not be useful, but so let us see this approach. Now see this. Suppose if I take cross product with p cross r on either sides, this will be p cross p plus p cross q. So being the cross product with same vectors is always equal to 0, you can replace this with 0, and then this will be p into r into sine of angle between p and r. So p and r is alpha, sine alpha is equal to 0 plus p into q into sine of angle between p and q is sine alpha plus beta. Then, so this is p and p will cancel out, and what we left over is q is equal to r sine alpha by sine alpha plus beta. This is how actually you can find out the unknown value of q. R sine alpha divided by sine alpha plus beta. Now, if you take r is equal to p plus q, but the cross product with q now, q cross r is equal to q cross p plus q cross q. So this is q r, sine of angle between q and r is beta is equal to q cross p is q into p into sine of angle between these two is alpha plus beta. Now q will cancel out, p is equal to r sine beta divided by sine alpha plus beta. This is how actually you can divide the two vectors into its components. Got it? Okay, so you can note down this. Now actually one particular case of this is when alpha plus beta is equal to 90 degrees. So when alpha plus beta is equal to 90 degrees, then actually we can derive from this equation itself. So if alpha plus beta equal to pi by 2, then the denominator in either case is equal to 1. Then r sin beta and r sin alpha are the two components. So one component q is equal to r sin alpha and p is equal to r sin beta. But if alpha plus beta equal to 90 degrees, then one thing, maybe actually beta can be replaced as pi by 2 minus alpha, because alpha plus beta is equal to pi by 2. Now if you replace here, sin pi by 2 minus alpha is cos alpha. So p is equal to r cos alpha. So this is how actually we have divided the vectors, the horizontal component and the vertical component. Got it? This is one particular case. So this is a general case. Fine, you can note down this. Done? Okay. Now, I'll give you one more problem. Try to solve here itself. The resultant of, sorry, I'll give you a different one. So the greatest resultant which two forces can have is, P, and the least result is Q. So that if they act at an angle of theta, show that if the two forces act at an angle of theta, the resultant is of magnitude p square cos square theta by 2, p square cos square theta by 2 plus q square sin square theta by 2 whole power 1 by 2. Can you try to prove that? The greatest resultant which two forces can have is P and the least resultant is Q. Show that if the two forces acts at an angle of theta, then the resultant is equal to p square cos square theta by 2 plus q square sin square theta by 2 whole power 1 by 2. Anybody got idea about this problem? Any idea how we can solve? See, so two vectors can have maximum value only when these two forces acts exactly on the same direction or on the same line, right? So that means greatest magnitude is P, and that happens, let the forces be F1 and F2. Then the greatest magnitude P is equal to F1 plus F2, because if these two acts exactly on the same line, then this is equal to the maximum value. And similarly, the least can happen if f1 minus f2. Least can happen in this manner, right? So Q is least and P is max. So from this actually you can find out f1 value and f2 value. Then you can substitute resultant is equal to f1 square plus f2 square plus 2 f1 f2 cos theta. So this is how actually you can find out. You try to prove on your own now. So f1 is nothing but p plus q by 2 and f2 is nothing but p minus q by 2. I hope everybody got the answer for this. Anybody got the answer? Okay, great. So I think so this is straightforward. You substitute here, so you will arrive at this result. So nothing great about it. Okay, so note down one more. The resultant of the forces P and Q is the resultant of the forces P and Q is R. If Q is doubled, then R is doubled in magnitude. R is doubled in magnitude. If Q is reversed, R is again doubled in magnitude. R is again doubled in magnitude. Find the ratio P is to Q is to R. Try to solve this. So Nawaz, that's not correct. The resultant of the forces P and Q is R. If Q is doubled in magnitude, R is also doubled in magnitude. If Q is reversed, then again R is doubled in magnitude. Then find the ratio of P is to Q is to R. It's not that easy. So there are three different relations. One is r square is equal to p square plus q square plus 2pq cos theta. And the second one is, so if q is doubled, that means r is also doubled. Only magnitude is doubled, but not the angle. And the third equation is, this is equation number 1, this is equation number 2, and the third equation is q is reversed, but magnitude is same. That means again this r is doubled. P square plus q square 2 into p into q into cos pi minus theta, because it is reversed. So this equation you can write this as, so this equation I'll write it first. 4r square is equal to p square plus 4q square plus 4pq cos theta. This is equation number 2. And this equation is 4r square is equal to p square plus q square minus 2pq cos theta. Now you need to solve all the three equations. So equation number 1 and equation number 2 and equation number 3. You need to solve these three equations and then try to arrive at p is to q is to r ratio. Try to solve this. Anybody got it? Now let me solve this. From equation number 1 and 3, so equation number 1 is r square is equal to p square plus q square plus 2pq cos theta. And third equation is 4r square equal to p square plus q square minus 2pq cos theta. Right? Yeah. So if you add these two equations, then actually 2pq cos theta will cancel out. Then 5r square is equal to 2p square plus 2q square. So this is equation number. So I call this as 2p square plus 2q square minus 5r square equal to 0. This is equation number 4. And from equation number 1 and 2, okay, so or else actually you can take equation number 2 and 3, then actually, so 4r square is, this is 4r square. So multiply the third equation with 2 and then I will try to add these two. So equation number 2 plus 2 times of 3. It implies, so equation number 2 plus 2 times of equation number 3. So 2 times of equation number 3 is, this is 8r, and 8r plus 4r is 12r square is equal to, and this is 2p square plus p square. This is 3p square and 2q square plus q square. This is 3q square and this will be anyway 0. So then from this 3p square plus 3q square minus 12r square equal to 0. So now actually this equation number is 5. So from these two equations actually you can find out the ratio. So if you wanted to solve 3 different variables but only 2 equations, then the standard method you can apply. So p square, I'll write this equation here first. 2p square plus 2q square minus 5r square equal to 0. This is equation number 4. Now this is p square divided by AD minus BC. So minus 15 plus 24. Minus 15 plus 24 is equal to q square by minus 12 into 2 minus 24 plus 3 into 5 15 equal to r square divided by 6 minus, there is something wrong. So equation number 2 is 4r square is equal to p square plus 4q square plus 4pq cos theta. This is correct. And this one 4r square is equal to p square plus q square minus 2pq cos theta. This is also correct. Yeah. Now actually equation number 2, oh, this is wrong. Yeah. 4q square plus 2q square. This is 6q square. This is wrong. Yeah. 6q square and these two 4 plus, yeah, this is correct. So this is actually 6. That is the only difference. Yeah. So from this actually we can rewrite this. P square divided by AD minus BC. So 6 into 5 minus 30, or actually you can simplify further this equation. P square plus 2q square minus 4r square equal to 0. So after further simplification, so I have divided with 3, and this is p square divided by minus 8 plus 10, minus 8 plus 10 equal to q square divided by minus 10 plus 8 r square divided by 4 minus 2. Yeah, so this is the one. So finally we arrived at p square by 2 is equal to q square by 2 is equal to r square by 2. Okay, so I'll erase this. Yeah, I'll erase this and redo from here. You note down till this point. I'll do it here. So these equations, what we have got is, one is 2p square plus 2q square minus 5r square equal to 0. This is equation number 1. And the second one is p square plus 2q square minus 4r square equal to 0. So from this actual p square by minus 8 plus 10 equal to q square by minus 5 plus 8 equal to r square by 4 minus 2. Yeah. So this is p square by 2 equal to q square by 3 is equal to r square by 2. So if you take square root of this entire thing, p by root 2 equal to q by root 3 equal to r by root 3. So r p is to q is to r is equal to root 2 is to root 3 is to root 2. So this is the answer. Got it? You got any questions? So this is straightforward simplification. So we have got 3 different equations based on the statements. We have solved those 3 equations. So 3 equations. So we brought into 2 different equations, and 2 different equations with 3 unknowns. Then the result is actually can be expressed only in the form of the ratio. We cannot straight away solve the values of PQR because only 2 equations we have got. Got it? Okay, yeah. So now actually we'll start with Lami's theorem. So this is one of the popular theorem, and this is applicable only for the forces under equilibrium condition, and that too only 3 different forces. So what Lami's theorem states is, if 3 forces are equal, if 3 forces are in equilibrium, if three forces are in equilibrium, then the forces can be expressed as so this is as if like sine law. So that is A by sine of angle A is equal B by sine of angle B is equal C by sine of angle C. So this is actually Lami's theorem. But so if these three forces are actually forming a closed triangle, that means the system of three forces are under equilibrium condition because there is no effective force of all the forces together. Suppose let us say there is a body like this. On this body, there are three different forces that are acting. Let us say there is one force that is acting at this point, and there is one more force that is acting at this particular point, and there is one more force acting at this particular point. Now this is F1, and this is F2, and this is F3. Now actually, if you try to form these three forces as a closed triangle, let me draw that. See this. I'll take this force first. So this is first force, and then from there actually, this is the second force. This force actually I have drawn. So this is here and this is here. And this force, if I draw it, this will form the closed triangle like this. So all the three forces so are forming a closed triangle means, so whatever the force this is applied at this top of this, so this is supported by these two forces. And this is under equilibrium condition, hence there is no movement for this particular body. In such kind of situations, definitely all the three forces together will form the closed triangle because as the stability condition says that, so F1 plus F2 plus F3 is equal to 0. This I proved earlier. So suppose this is F1 and this is F2 and this is F3. The sum of F1 and F2 obviously equal to minus F3. So F1 plus F2 is equal to minus of F3, or F1 plus F2 plus F3 is equal to 0. Now under such kind of situation, how we can express this as, so A by sin B is equal, B by sin B is equal to C by sin C, or this can be even expressed as this format. So this is F1 and this is F2 and this is F3. So from this format actually, so F1 by sine of angle between F2 and F3 is equal to F2 by sine of angle between F1 and F3 is equal to F3 by sine of angle between F1 and F2. So this is what is the Lami's theorem. Now actually you note down this, I am going to prove this. Done? Noted down? Okay. So let me prove this. If three forces are under equilibrium condition, then so if the three forces PQR are under equilibrium condition, then P plus Q plus R equal to 0, obviously. And for this relation, if you take a cross product with P, then P cross P plus Q plus R is equal to 0, or P cross P plus P cross Q plus P cross R is equal to 0, or P cross Q is equal to minus of P cross R. So this is the equation number 1. So because P cross P is equal to 0 and P cross Q, you can keep it here, and P cross R actually you can take it to the other side. Or P cross Q is equal to R cross P. So this is equation number 1. And if you take the second relation, that is, if you take the cross product with Q, then Q cross P plus Q cross Q plus Q cross R equal to 0. So from this relation, Q cross P is equal to minus of Q cross R. Right? So R P cross Q is equal to R cross Q. Sorry, Q cross R. Yeah. So P cross Q is equal to Q cross R. So I have taken the sign opposite for 1. So from this actual P cross Q is equal to R cross P, and here P cross Q is equal to Q cross R. So from all the three relations you can write P cross Q is equal to R cross P is equal to Q cross R. Right? This is how you can write it. Now from this relation you can write this as, so PQ sine of angle between these two, P and Q, is equal to R into P into sine of angle between R and P, and is equal to Q into R into sine of angle between Q and R. Now if you divide this entire equation with PQR, then sine of PQ divided by R is equal to sine of RP divided by Q is equal to sine of QR divided by P. So this is what is the Lami's theorem. Got it? Understood? So whatever angle you take it, so the opposite one actually it will come at the denominator. It is as if like sine rule. So A by sine A is equal to B by sine B is equal to C by sine C. So that's exactly what we have done here, right? Lami's theorem, now actually it is applied a sine rule for the triangle, right? So it's exactly more or less same. Now here, so if these are the three forces that are acted upon at this particular point, these three forces definitely will form a closed triangle. If this is the case, then actually the angle between P and Q, suppose if this is P and this is Q and this is R, then sine of angle between the opposite force. So R is this force, angle between P and Q is this one. Now this force divided by sine of angle between R and Q, and this force divided by the angle between R and P, like this. So these three are equal. So if you remember this diagram, so you can easily apply Lami's theorem. So opposite angle, sine of. So ratio is same. Got it? So any questions on this Lami's theorem? So this is actually one of the very, very important principle that will be used to solve many of the statics problems, because actually most of the times actually we'll be dealing with the forces only 3 in nature. So actually not very great number of forces will be given in the exam. So usually 3 forces will be given, and that too with the application of this Lami's theorem. Done? Noted down? Okay, great. So now actually I will give you one problem which was given earlier in UPSC based on this Lami's theorem. Note down this problem. One end of a light inextensible string. One end of a light inextensible string of length L is fastened is fastened to the highest point of a smooth circular wire. To the highest point of a smooth circular wire. Smooth circular wire of radius A, which is kept fixed. Of radius A, which is kept fixed in a vertical plane. The other end of the string is attached to a small heavy ring, is attached to a small heavy ring of weight W, which slides on the wire. Which slides on the wire. Find the tension of the string and the reaction of the wire. Okay, so this is the problem actually which was given earlier in UPSC. Now here actually, so let me explain some of the fundamental concepts before solving this problem. One is actually, so there are certain words actually which were never used earlier. So one is actually, so reaction of the string. So this reaction is a new word. And actually, and another one is tension in the string. Somewhere tension is there. Find the tension of the string. This is one statement. And another is actually weight is a new word. Weight. Now actually let me give the explanation of these words. Now usually like actually there is something called mass and there is something called weight. So mass is nothing but the matter that is present on any particular physical body is called mass. So that means if I take this particular chalk piece, on this chalk piece it is built with almost infinite number of tiny particles of this chalk, right? So this tiny particles is accumulated as if like it is a mass. But this mass is a fixed quantity of the matter. But the location of this mass does matters in case of weight. Suppose if I keep this chalk piece here, now this is under the influence of the gravity due to earth. Suppose if the same chalk piece is taken to the moon, then the matter actually it won't make any difference. They're exactly the same mass, but the weight is different in moon. Now if I take to Mars, then actually there the gravity will be different again, the mass will be same, but the weight will be different. That means weight is a variable quantity depending upon the location where we are working. But mass is a fixed quantity that depends just on the body, right? So this is a difference. Now, so weight actually is nothing but mass times acceleration due to gravity. So this acceleration due to gravity, this is fixed for Earth. And this is usually of magnitude. So G is equal to 9.81 meters per second square. Now actually this value is of very much important for us. Now this value 9.81 meters per second square, meaning if I leave this chalk piece here, now the velocity of this particular chalk piece keeps on increases. That means it starts with 0 velocity. The moment it comes here, it will have a little more velocity, and the moment it comes here, it will have far more velocity than the earlier. And if it goes a little down, again the velocity is changing. That means it keeps on changes. And one important aspect is, suppose if I take this chalk piece and if I take this cell phone, now if I leave these two together like this, these two, though the mass is different and the weight is different, but still these two will take exactly the same time to reach the ground. Got it? So many people think that actually, so bigger the mass, faster is the fall, but it's not the case. That's what is the Galileo's experiment. So go to the top of the building and leave one chalk piece and maybe a bigger stone, and both will exactly reach at the same time on the ground. So that's the Galileo's experiment. So which proved that this G value is same. That means these two will be having the same acceleration on the ground. That means when it is moving, the velocity that is increased is equal irrespective of the size of the matter. So that's what is called as the G, or acceleration due to gravity. Change in the velocity is called acceleration, and that acceleration is just caused by the gravity. Gravity means the earth influence on the mass. So that is equal on all the masses. So that value is 9.81. Now, if you take one particular ring, so he said that actually there is a ring of weight W. That means this ring is having a mass of M and it is having a weight which is equal to M into G. So weight is nothing but force. It is a force. Weight is a force, but mass is not a force. Mass is just a matter. And this force is nothing but with what force it is driving towards the ground. That force magnitude is nothing but, so that force magnitude is nothing but the weight which is given by mg. So as we know, F is equal to ma. As per the Newton's second law, this A is caused due to F, hence A is replaced with G. So weight and force are one and the same. Weight is just cause if you lift the chalk piece to certain height, automatically there will be a force that is acting on this and it towards the ground. That force magnitude is nothing but weight, W here. And the tension is nothing but, if there is a wire or a thread, then actually if you tie up your stone to the thread, then if you just leave it, there will be a force towards the ground on the stone. If you hold that string like this, then the counter force that is acted on the stone towards top, which is the counter force to the acceleration due to gravity, and that is nothing but is influenced by the stone on the string. That influence caused on the string is called as the tension. Tension means it is trying to push back. Got it? So the moment you apply the force down, it will try to push up. Whatever the force you apply down, it will equally apply on the opposite side. So that's what is called as the tension. That means, so this is a mass. So this mass is having a weight towards ground W. Then automatically, if you hold this particular string like this, there will be a counter force that will be developed on this particular string, and this is what is called as tension. Tension is term for the internal force of this string. Weight is external force that is acted on this particular stone towards the ground. If you apply an external force F with your own hand, and this is the external force that was given. This is external, but tension is internal. That got influenced by the external forces. Got it? You understood? Understood what is weight and what is tension? Yes or no? Okay. So, and one more term is reaction. So the reaction means, suppose like actually, so we are standing on the ground. Now, so the grip actually that is coming from the ground is nothing but the counter action by the ground on our body. That means because of your weight, you are kept on the ground, and there will be a counter force that was put on our feet towards upward direction. So these two forces together will be balanced on the ground. That's why we were able to stand like this. So there will be a counter force on the feet from the ground towards exactly upward direction. Now, this is a reaction that was caused only when we stand on the ground, or if we keep something on the ground, then only the reaction will come. Otherwise, there won't be any reaction. Suppose if I take this particular cell phone like this, and this cell phone, so as long as actually if I don't keep the cell phone on my hand, there won't be any counter reaction on this particular cell phone, or actually this surface is not having any other force other than the ground force that is acted on this, right? And then if I put this cell phone like this, then this cell phone is standing on my hand just because of the reason the weight that is caused by the cell phone towards the ground is counteracted by my hand in the opposite direction, in the upward direction like this, exactly on this particular surface, at the bottom surface. Got it? So this counter force is called as the reaction. That reaction is coming because of the action of keeping the cell phone on my hand. Got it? So reaction is influenced by the action always. If there is no action, there won't be any reaction. So this is as per Newton's third law. For every action, there will be an equal and opposite reaction. Unless you have the action, then only, right? So unless you have the action, you won't have the reaction. So if you have the action, then the reaction will come automatically, right? So here also, this is the reaction caused by the hand on this particular cell phone. This weight downwards and the reaction upward both are balanced together on the surface of my hand. Hence, this cell phone is standing here. Otherwise, it will go down. Got it? If I don't give this support, that means if I don't give the reaction upward, it will go down automatically, right? So this reaction, in which direction it comes, that does matter. So the reaction, as a blind rule, you always remember that that's exactly perpendicular to the surface on which it stands. So if there is a surface like this, then if there is a body that is present at this particular point, then the reaction will be exactly perpendicular to this tangent at this particular point. Got it? So if there is a flat surface like this, and if there is a body like this, the reaction will be perpendicular to this surface where this body is standing. Now, suppose if I hold like this, suppose if I have a rod like this, the reaction at this particular point will be, so draw a tangent like this and then perpendicular to the tangent, the reaction will be there. And even here also, so this is the tangent and this is the normal direction. So this is perpendicular to this surface. There is a tension that is acting because of the rod that is slant like this. So whatever may be the direction it is, the surface decides the reaction direction. So many people think that the body decides the direction of the reaction, but it's not. So the direction of the reaction is always perpendicular to the surface where it is standing. Got it? So here actually you can give that. Suppose actually if this is on the top, then actually the reaction will be like this. Suppose if it is on this side, then the reaction will be like this. So because of the reaction only it will fall down, because if it is on the other side. So this is a surface of a vessel, let us say. So this is a vessel and then on this vessel there is a ball like this. Then actually the reaction will be opposite to like this. If you keep the ball outside, automatically it will push out. So it will go down. Got it? Now actually, so coming to our problem, I hope you understood what is reaction, what is tension and what is weight. If you understand this, then only you will be able to solve this problem. Any questions on this? Okay. Now actually we will see this problem, what he has asked for. So one end of a light inextensible string of length L is fastened to the highest point of a smooth circular wire of radius A. That means there is something called a smooth circular wire of radius A. So this is a smooth circular wire and the radius of this is A. So this is the topmost point. And light inextensible string. String means there is a thread kind of thing. So let us say this is a string of length L. And this is on the smooth circular wire. And one end is fastened at the topmost point. So which is nothing but the highest point. So this is the radius A. And obviously this will also be the radius A, right? Okay. So which is kept fixed in a vertical plane. So this circle is fixed on the vertical plane. So let us say there is a support on this particular ring. The other end of the string is attached to a small heavy ring. So one end is fixed at this location and other end is fixed with a small heavy ring. So this is small heavy ring. And then which is a small heavy ring of weight W which slides on the wire. So that means if you keep this particular heavy ring here, automatically it will come down like this and then actually it will be present at this particular point because of weight of this particular ring. Now this ring is having a weight of W. Weight always acts downwards towards the ground. So irrespective of the position, the weight direction is always towards the ground. Right? So this length is L, the radius is A, and the weight is W. And then obviously on this particular ring, so there will be a counter reaction, right? So the reaction will be outward like this. That is exactly tangent. If you draw a tangent like this, that will be perpendicular to the tangent. So this is the normal direction. So normal direction is always the radial direction. So this is the radius of the ring. So this circle radius is this one. On the radius only the normal will be present always. And tangent will be just touches the circle and go. So this is the tangent direction. Now here, this is the weight direction. Let us say this angle is theta. And this angle will be how much? What is this angle? So this is exactly the same. Now, if I extend this line like this, what is this angle? What is that angle? Is it 90 minus theta? So angle APB is how much? Angle OAP is equal to angle OPA is equal to theta. And what is angle APB? So this angle I am asking. This angle. It's again theta, exactly. Why? Because there is a statement saying that one end of the string is attached to the highest point of the circular wire. So if it is the highest point, then this will be exactly a vertical line, right? And this is also a vertical line because weight always acts downwards vertically. That means if these two lines are drawn like this, and then if I put this way like this, obviously if this angle is theta, this angle is also theta, right? So these are alternate angles. Got it or not? I hope everybody understood. If this is theta and this will also be theta. Now here actually our goal is to find out this reaction R and this tension T. So this tension T. Sorry, tension is on this one, on the string. So this is the string and this is the reaction direction. This is the weight direction. So there are three different forces now. So one is this direction, another is this direction, another is this direction. Like this. So this is reaction, this is W, and this is tension. So now actually the ring is kept at this location because of the balance of all the three forces, reaction, weight and tension. So if all the three are getting balanced here and there are three different forces that are getting balanced, you can safely apply the Lami's theorem. Now to apply the Lami's theorem, what you need to know is you need to find out this angle, you need to find out this angle, and you need to find out this angle. So for that, so let us start with theta. Then obviously this angle is also angle APB is also theta. Now actually we can apply Lami's theorem. First you find out these angles. What is the angle between R and W? in terms of theta? Two theta, obviously. This is one theta, this is another theta. This is a kind of X kind of shape. So this is 2 theta. Obviously, this will also be 2 theta. So this is 2 theta. And what is the angle between T and R? What is the angle between T and R? So this is actually, if we extend like this is making an angle of theta. Obviously, one straight line will make an angle of 180 degrees. If it is 180 degrees and then theta is less, then obviously this will be pi minus theta, right? Yes or no? Yeah. Now actually, what is the angle between T and W? What is the angle between T and W? The sum of all the three angles should be equal to 360. Or otherwise, actually, you can find out from here also. So this angle is 180 degrees, right? And then this 1 theta added and 2 theta subtracted. So again, it will be pi minus theta. Or if you add all the three together, it has to result into a 2 pi. So obviously, this will be, so 2 pi minus theta plus 2 theta. So this will be 2 pi minus pi plus theta. So this will be pi minus theta again. Now you have got all the required quantities for the Lami's theorem, right? So you can apply Lami's theorem on this. So for applying Lami's theorem, you can write T by sine 2 theta is equal to W by sine pi minus theta is equal to R by sine pi minus theta. So from this actually, T by 2 sine theta cos theta is equal to W by sine pi minus theta is sine theta is equal to R by again sine pi minus theta is sine theta. This sine theta, this sine theta, this sine theta will cancel out. Got it? From this actually, you can further simplify as T by 2 cos theta is equal to W is equal to R. You note down till this point, then actually we can express into the known values of this theta. Got it? Noted down? Then okay. So from this relation, T by 2 cos theta is equal to W is equal to R. Now cos theta, theta is unknown. We randomly brought into picture down the line. Now actually the values that were given were, one is the radius and another is this length L. Now if you draw a perpendicular from here, obviously this will be L by 2. And so from this actually you can find out the cos theta value as, so cos theta is equal to, so this is actually, if you draw a perpendicular, this will be 90 degrees. Cos theta is equal to L by 2 divided by A. So because this is the hypotenuse. So L by 2 divided by A. So you can replace L by 2A cos theta. So if you put it here, T by 2 into L by 2A is equal to W is equal to R. This 2 will cancel and T is equal to WA by L. And so yeah, and W is equal to R. So in terms of weight, actually I have expressed everything, both tension and reaction. Let me check the answer. Yeah, that's correct. Got it? Understood? how we are solving this kind of problems. So essentially, when we are trying to apply the Lami's theorem, you need to identify the angles between the forces. But this is a little complex. It depends on the situation. So what kind of problem statement was given? You have to understand word to word. Each word has to be carefully observed. So like actually identification of this angle is quite tough here, because if you leave the word that actually at the top of the circular wire, actually one end is fastened. If you leave that statement, obviously you will lose control on this angle. So every word is important. In statistics, actually the main problem is from the problem statement, identifying the drawing is very, very important. So if you miss something there, then obviously you cannot solve that problem. Got it? Yeah. So this is about Lami's theorem. So I'll be solving. So I think so few more problems tomorrow. So I'll stop the class for today. If you have any questions, you can let me know now. Any questions? Any questions? Okay, yeah. So if there are no other questions, so I'm going to stop the class for today. Yeah, thank you. Good night.